ever thought, what if I just dug a really, really deep hole? That's what the USSR did right here. That hole is deeper than the deepest part of the ocean. It's deeper than Mount Everest is tall. They started digging it in the 1970s as part of basically a space race, but down. The United States only got to 600 feet before pulling funding, but the USSR kept going for 20 years. They made it about a third of the way through Earth's crust, and then stopped. But what if you just kept digging? If you dug a hole all the way to the center of the Earth, what would you find? What would happen to you? And what does our newest tech tell us is really going on down below our feet?
Let's take a look at what's inside.
Journey to the center of the Earth.
Went where no human being had ever set foot.
We're still falling!
The center of the Earth.
The heat and the pressure.
What's underneath the Earth's crust is different.
The deeper you go into the Earth, the hotter it gets.
That's wild. Imagine we go outside and we just start digging. At about 50 meters deep, we might start to feel the temperature go up. Every kilometer through the crust is about 25 degrees Celsius hotter. Right now, we're inside the crust. On land, it's typically less than 40 kilometers deep, which is less than the length of a marathon. We're passing through soil and layers of hard rock, past precious metals and fossils. And as we get deeper, we start to see all kinds of impressively deep things that people have built. Like there's the Chemioka and Sanford research labs that do dark matter and neutrino physics research. Or there's China's insanely deep nuclear command bunker. There's the deepest cave we've ever discovered, plus some of the deepest mines in the world. As we go deeper, temperature and pressure continue to rise. But by this point, unprotected, just in the Earth, we were crushed and crispy a while ago. To go farther, let's equip ourselves with an imaginary drilling machine that's immune to any temperature or pressure. Now, finally, at 12.2 kilometers, we reach the deepest point humans have ever dug. This is that hole the USSR dug, the Kola Super Deep Borehole. They didn't put any humans down here. This equipment was operated remotely. To get so deep, these scientists had to invent new equipment and drilling methods to pierce through the thick, hot, pressurized rock. Along the way, they discovered new fossilized organisms dating back 2 billion years, and found there was water, much deeper than scientists previously thought. We actually emailed 3 of the scientists who worked on this project, and one of them told us, quote, "The Russians tried several times to get down past the maximum depth that they had reached, but each time, the new hole tended to collapse. This was a moonshot, which will never be repeated or surpassed." This is so cool. But the craziest part is, this deepest hole that humans have ever dug is only 0.2% of the way to the center of the Earth. Time to go deeper. At about 30 to 50 kilometers down, we notice that the rock around us is changing. We're crossing into the mantle. At first, the rock around us looks really brittle, like the crust, but denser. But as we get a little deeper, as the temperature rises over 1300 degrees Celsius, something weird starts to happen. The rock around us starts to look like hot plastic. Here, the temperature is higher than the melting point of the rock, but the pressure is so high that it's still keeping the rock solid. It's gooey. We're now starting to push through even hotter material. It's slowly inching from the bottom of the mantle toward the top in these giant convection currents over millions of years. And you might be wondering, why is the Earth hot? Well, it's partly radiation and partly leftover heat from when the Earth formed by meteorites smashing against each other over and over again. The Earth is cooling very, very slowly, but we don't need to worry about that. It's going to take billions of years. In the meantime, this stirring of hot goop brings enormous amounts of heat from the center toward the crust. But hang on, how do we know that? If humans have only ever been 12 kilometers down, how do we know that?
Yeah, that's a great question.
That's Dr. Megan Newcomb, a geologist and volcanologist at the University of Maryland. She told me that studying the deep Earth is like being a detective.
We can't get there, so we have to put together all of these indirect pieces of evidence to work out what's going on down there.
Ancient scientists had a lot of theories about what was going on down there. Some thought the Earth contained a central fire with underground lakes and lava chambers. Some thought it was hollow, maybe a set of concentric shells with life on each ring. This is the basis for the hollow Earth in the Godzilla movies. Isaac Newton suggested that based on observable gravity, the stuff in the center must be denser than the stuff at the top. But it wasn't until the early 20th century that scientists could prove that the Earth had a central core, and that there were several different layers above it. These breakthrough discoveries were thanks in large part to earthquakes. During an earthquake, we feel it up here, but it's also sending seismic waves down.
They are just like sound waves, but there are two main varieties. There's P waves and S waves.
P waves can travel through liquids and solids, but S waves can only travel through solids. They also behave differently depending on the density of the rock that they're moving through, which means that by measuring what waves end up at different detectors all over the surface, scientists can understand what's going on between them. That's one big way that we've learned about how the mantle differs from the crust, and it also taught scientists something else.
We find this S-wave shadow on the opposite side of the planet that tells us that for some reason the S-waves couldn't propagate all the way through the Earth. And that tells us that there's a liquid layer down there.
That liquid layer is part of what we now call the outer core. We've now crossed into a liquid soup of metals, cooking at around 4,400 degrees Celsius. Here, temperature has won the fight against pressure, and we should all be extremely grateful for the hot metal soup down there, because its constant churning generates enormous electric currents, which in turn create the magnetic field around the Earth. And without that, cosmic radiation would just end all life as we know it on the surface. But this gets weirder. Our magnetic field sometimes actually just reverses. The North and South poles slowly swap places. And we know that because
you can actually read off all of those magnetic reversals on the ocean floor.
Yeah.
As basalt is erupted along our mid-ocean ridges, it freezes in a record of what the magnetic field was at that time. And as the plates continue to get created and pulled apart, we can read them off like a barcode.
So what you're telling me is there's a barcode for our magnetic fields at the bottom of the ocean, and scientists have learned to read it. Excellent. You can read this too. It flipped here, it flipped here, it flipped here. The last reversal was around 780,000 years ago. When will it flip next? We're not sure. But I had a much more basic question about all of this. Why is the Earth in layers?
You're gonna like this one. At the beginning, we were a magma ocean. The entire Earth was molten liquid. During that time, the densest materials, which are the iron metal, and sank and formed the core. And then the lightest minerals floated to the top, and the densest minerals settled to the bottom. And so we've segregated by density.
Okay, we've almost made it through all of those layers. We are deep inside the Earth's outer core. And then you hit something. Hang on though, if you're going on a real life adventure, you might want to take this. This is my water bottle. This is the Lark PureViz 2. And what's cool about it is that when I press this, it's purifying the water inside. It uses UV light to break down the chemical bonds of bacterial DNA, specifically E. coli and Salmonella. That keeps the inside clean compared to a water bottle without that. In this example here, they swabbed the inside of 2 water bottles used for 4 weeks. Lark is on the left and a water bottle like the one I used to have is on the right. Then they waited to see what bacteria grows from each, and the PureViz 2 also has a plant-based filter that removes pollutants, so better taste, healthier water. Plus, and this is my favorite part, it helps me remember to drink enough water. This is my real data from the last week. You can see I'm hitting my goal almost every day. The way this works is it has a little sensor in the cap that measures the water level inside after each sip, so I get real-time insights on my progress. The light ring on the cap will light up to remind me to drink water, and you can set the frequency of that in the app, so I have mine set to every hour. And it has a double wall insulation that keeps water cool for 24 hours. If you want to check it out, there's a link in my description. Now, back to the story. At the very center of our planet, there is a solid metal ball that's almost as hot as the surface of the sun. And for a long time, we didn't know it was there. We assumed that everything in the core was molten, because why would it be solid? But then, these 2 scientists were studying more of those seismic waves, and they noticed that when those waves got to the center, they started to act weird. Waves were being bent and reflected by something in the middle. The math only made sense if there was a solid core inside the larger liquid one. Other scientists confirmed this theory, with more precise recordings of the waves and better computational models. So why is it solid? Well, it turns out that the pressure here is so insanely high that the iron atoms literally can't move. And what's even stranger is that more recently, scientists have found slight discrepancies in the data that seem to show Earth's core is rotating at a different rate than we are at the surface. And that rate changes. It is speeding up and slowing down separately from what we're doing up here. Because Why not? Very precise seismic data and computer models of our magnetic field show that the Earth's inner core seems to be speeding up and slowing down on a roughly 70-year cycle. You might have seen headlines that the Earth's core is reversing, but that's not true. It's just that if you were on the outside of the inner core and I'm on the surface, it would look to me like you were going the opposite direction if you're slowing down, even if we're both moving the same direction. But this iron core is no match for our magical digger. We are going straight through it until finally, we did it. We made it to the very center. We are now 6,400 kilometers from the surface. The pressure around us is 3.6 million times what it is on the surface. But in lots of ways, what's around us right now is still a big mystery. Like, is there an inner core? Some scientists think that there might be. There's new seismic data that suggests that the iron atoms are packed differently way on the inside, but others aren't so sure that that's enough to call it a new layer. We've been wrong before, but we're becoming better detectives. Can we predict the Earth's magnetic field and when it might flip? Scientists are building experiments that mimic the inner Earth to learn more. Now the cutting edge is finding new ways to analyze